Hello and welcome to the TMC Newsroom. Thanks for watching. My name is Rich Tehrani. We are at Interop 2010 in Las Vegas. On our program today is Daniel Proch, who's with Netronome. Daniel, how are you?
I'm great. How are you?
Fantastic. So tell us a little. Well, I'm thrilled to have you. I'm dying to know more about your company. So could you tell us a little bit?
Sure. So we are a small startup of about 100 people developing a line of highly programmable semiconductor products for network flow processing. These are used in networking and communications of devices that need intelligent flow processing, virtualization, security processing, and so forth, unlike what you would consider a general purpose CPU. The intellectual property that we maintain is a line of, it's called the NFP 3240. It's a 40-core network and security optimized RISC microprocessor. As I said, optimized around network and security processing. It legitimately is a 40 gigabit per second NPU. From that line of NPU products, we also build a family of acceleration cards based on that network flow processor, as well as full systems solutions that scale up to 100 gigabits per second worth of processing, again, using the NFP technology.
So you've got companies like Intel in the market, in the processor market, making general purpose processors. You've got TI making a whole bunch of interesting processors. And more recently, I'm hearing about companies using graphical processors as other types of processors. How is your technology different than some of those other areas or some of those other markets?
So first things first is we're not a general purpose processing core. The device is heavily optimized around packet processing, flow processing, as well as security, cryptography, and PKI. So you wouldn't use it as a general purpose processor. But unlike a lot of other processor companies that are out there, what our philosophy is somewhat different. We believe that that there is a place for those general purpose processors. They are well suited for certain tasks. Of them, it's not network and security processing, though.
Right.
So the architecture that we promote is called a heterogeneous multi-core processing architecture. So the paradigm is such that you couple x86 general purpose processing cores that are the best in the market. You're not going to beat Intel for price, performance, continuity of supply, and innovation. Intel's the market leader in general purpose processing. But there's certain bits of functionality that could be best done on another specialized processing core, which is those network flow processors. So it's this cooperative processing environment that we see really allowing applications to scale from to 10 gigabits per second, 40 gigs, and 100 gigs going forward.
Now, I would imagine as virtualization continues to take off, the server processors are going to be taxed almost to the max anyway, right? So people are trying to get data centers are trying to get 70-80% utilization on these CPUs, leaving not too much left for areas like maximizing the throughput, right?
Yep, you're totally right. And we've really spent a lot of time trying to solve that very issue. When you start thinking that you're already, just by collapsing physical devices into one virtualized device, you're right, the CPU utilization there is going to be dramatically higher. And the problem's actually worse than that. It's that all of these virtualization technologies, be it Zen, VMware, Hyper-V, the way you get traffic in amongst the VMs from the I/O is through an Ethernet switch in software. It's based on MAC addressing, okay? And so that alone takes up an entire CPU core or more just to get packets into the system and direct them right to the appropriate virtual machine. So in the processor design, we've built I/O virtualization into the processor as base technology. So you can consider this. Networks have been virtualized for years. We know about MPLS, VPNs, RFC 2547, VLANs, IPsec VPNs, SSL.
Right.
It's been around forever.
Sure.
The way to take a physical resource and use it for multiple virtual instances.
Sure.
Now we're doing it on the operating system side as well, right?
Sure.
The missing link there, though, is a way of getting packets from the network into the right virtual machine with dedicated resources. Absolutely.
Right.
So we've implemented an enhanced version of the PCI specification for IOV. So now you can have a dedicated resource from the I/O card, which is one of our network acceleration cards that we build, across the PCIe bus into the right virtual machine, and get bandwidth guarantees and latency guarantees. So now we've really connected these two virtual universes over a virtualized I/O.
So, and you really, I mean, this is something you're going to need because you've got 40 cores, right, in just general purpose processors in a lot of these in servers, or more now, right?
No question about it.
I mean, it's just insane how many processors you're going to be fitting into the next gen servers, and dealing with this issue has got to be done now because it's only going to get worse.
Yeah, it's
right?
a baseline requirement. Any network interface card that's out there these days has to support some level of I/O virtualization to get packets into those cores efficiently, or you're literally wasting a very, very large percentage of the CPUs themselves just for dealing with I/O. And so that's why our philosophy is let the network flow processor deal with the packet classification, flow classification, cryptography, and then provide an efficient manner of giving data into the x86 cores. That's the right way to scale applications going forward.
Is the NFP brand new?
We just started shipping the NFP in quantities to our customers in the first quarter, but it's not really a new part in that we licensed some technology from Intel for their IXP line of network processors.
Sure.
And we're building the follow-on to that line of NPU.
Okay.
It's a funny little story that Intel still to this day has north of 40% market share in the network processor business, but it wasn't in their core direction, and so they actually licensed that technology to Netronome, and we're going forward with it. And the beauty of the situation is we've given our customers a new code-compatible part with the predecessor to the IXP line, and now they've got a code-compatible part that they could build their next-generation designs on. They don't have to go to an entirely different product architecture and start from scratch.
Well, that's good, right?
Absolutely, yeah.
Reduces a lot of complexity and extra work.
No question about it.
And do you have any new products coming out?
Yeah, we just announced 2 really exciting products here at the show based on the new NFP line of processors that we've just started shipping. The first is what we consider to be the industry's highest performance PCI Gen 2 family of network acceleration cards. So these are, it's a 6-port 1 gigi card as well as a 2-port 10 gigi card, and utilizes the NFP 3240 for flow processing to significantly accelerate what would be a standard x86 appliance by simply placing one of these network acceleration cards in the x86 server. We also announced a family of what we call the network flow processing platforms.
Right.
So these are full systems solutions available in either a 1U or a 2U configuration that, again, house our network acceleration cards.
Right.
But we further changed some things around. We've modularized the I/O. So there's actually three stages of processing. You've got these beautiful little modular I/O cards for 2 ports of 10 gigi, 4x1 gigi. We're going to have a 2-port 40 gigi card. Then those interface back to multiple versions of our acceleration cards, which then balance traffic into the x86 cores. So you've got now 3 layers of workload-specific processing that you can apply at various levels of the system. So at the I/O, you've got an Ethernet switch behind them. And so that you could do very coarse but very high speed, kind of layer 2, 3, 4 packet processing at that layer in the system. As you go deeper into the system, we balance traffic across the network acceleration cards, the NFEs, the network flow engines. And there you get very, very granular flow processing at 20 gigs per card. And then that traffic is further balanced across the multi-core x86. This particular system has dual IA Xeon 5600 processors. So it's a very, very high performing system. As I said, available in 1U and 2U. So you've got a family of platforms for application hosting that range from very, very low-end systems that might be 5, 10 gigs to the 2U system, and we even support clustered configurations where you could legitimately scale applications to hundreds of gigabits per second.
And that's where things are
That's what
going,
people
right?
need. That's what people need
And
right
that's
now.
probably the biggest trend you're seeing, I would imagine, is just the necessity for just faster and faster
No question about
processing and
throughput.
throughput.
40 gig, what we would consider to be cutting-edge technology last year, is real. It's in the labs. We've seen it here. We have one very close to coming out as well. And we're already taking questions about, hey, 40 gigs is great, but I need to go to 100 gigs and higher.
I've heard that as well.
Yeah, so we think that the architecture that we put forth, along with the network flow processor, is the right way to scale things to those appropriate levels. A one-size-fits-all processing architecture saying it's got to be all MIPS cores or all x86 cores is just not the way to move things forward. It's this cooperative processing environment that really are going to drive things to the next levels of bandwidth.
Well, that's fantastic. Thanks for coming and sharing with
Absolutely.
us. Absolutely. It's a
I
pleasure
really
to
enjoyed
meet
it,
you.
and thank you very much for having me. Great.